Hi, in this video I will quickly show different part of the Modular Snap System Runtime plugin tutorial level. So I will show different standard and rooms and just talk a little bit about what's going on here. Let's get started. Just to say, you can download this level and play with it yourself. There is a link in the description. So the first standard, we have the basic example of what the Modular Snap System plugin is and why, for which purpose it can be used. Here we have two cubes, and our player, it has the basic physics handle, so it can take things and release them. And those cubes here are just they don't simulate physics. So if I click on it, it will take it. I click again, it will release it. And if I approach one cube to another, you see this green ring appearing. So that's the preview of where it will snap. So if I release it here, you see it will go and snap to the another cube. Same thing like so. So that's it, what the Modular Snap System plugin about, the aligning actors like so. And here another example. Those cubes are simulating physics. So you see, if I drop it, it will fall. And here, if I snap a cube to another, it will not just align it, but it will also attach and weld it. Oh, you see, now I have a structure, so I can build those. And you see, when I grab one, I use the same physics handle that's before, the same actor, the same character, but I weld it. You see, I can now build something more complex. And like if let's do something like so, I can drop it without snapping it if I press space. Now I will attach this here and it falls. Now we have another example. Those are those guys, I'm sure, and those are static meshes, so we can take those and snap to the moving skeletal mesh. As you can see. Oops. Here we go. So all those examples use this character with its physics handle, which is not really part of the plugin itself. It's just one possible use, and you can it will be available with the example project when I will put the project for download. Now another kind of player here, it's the top-down view. So here we can select multiple pieces like in an editor and move them like so, they snap. And another thing this example illustrates is that we will check if those two pipes are connected, and every time we move something, and when the connection is detected, you see something will happen. like so, and you can also change the way the things are connected, and it will still work. And you see it also works with multiple selection correctly. Now, next room is about how do you use this plugin in your blueprints. For example, if you have to make a player, a character, or like this one we're using now, which nodes will you have? So first node, the more important and more basic node, call it snap actors, and it takes an array of actors and the settings, the options for the operation of the plugin, and then it returns you a value boolean to say if it's snapped or not, and if it's snapped it will return you the different numbers and different objects. The more important here is the array called new transforms, and it's the new transforms for those actors. So the snap, it actually, you know, it like moving them a little bit to adjust their position and their rotation. So this will contain those transforms for those actors. Actually, it will contain a little bit less than if we like pass some actors that are attached to some others, like we had here in the physics example with those cubes. It will only pass those that you really need to move, because the attached will be moved automatically. So this structure here, it's two entries, the actor to move and the new transform. There can be less of them that for the input, and then you can also know how they were connected, but we will look at that little bit later. So now that's the basic example of this operation. Use it alone and it will like that work. You see, check, really fast. This is because here you have a parameter search only, and if this parameter is disabled, it will really execute the snap, but it will execute it in one frame, in one tick, so it will not do this nice animation. If you want the nice animation, that's here. I call it smooth snap, and it's another node which is a smooth move, which is a latent node, so it's like a delay. You first execute snap actors with a search only set to on, so you only search for the new position but not really move anything, and then if it worked, you execute the smooth move and you can give the duration. Here we give 1 second duration, and then when it's finished it will return here, so it will take 1 second to proceed, like a delay. Here, let's take a look. Let's rotate it. I rotate it with the mouse wheel, and I click on the mouse wheel to you know, change the axis, so I can rotate it. So now if I release it, it will slowly go into position. That's because we gave 1 second delay. Usually it's 0.25 seconds, I think. So now what happens? We already seen a little bit an example of that in the previous room with those moving people and with physics actors. And what happens if you have a moving target? So like so, you have a cube with the movement component, I think. So if I snap to it, you see it works pretty good. And for those physics enabled things, if you want to detach, you press shift in this demo. But that's just the part of the demo, really. You can do it your way in your game. And here I have another one which now is stopped, but actually it's things that is attached to a physics constraint. So see, and you notice that it's every time it will be attached precisely, not. So you can imagine that when we calculate the snap between this time and the time the smooth snap plays, it will move the target. So there is a node called update snap result, which will take the snap result and track it for the case it moved, because the snap result that we can see here, it has all the necessary information of what was snapped to who. He can look at this target socket, which is a struct that contains also the actor, and it will see if this one moved because the actor moved, or because it's a skeletal animated mesh that moved its hand, for example, and will recalculate the transforms. So when we do smooth move, it will be taken into account automatically, like here. But for example, if you want to implement your own smooth move with some animation, some special effect, I don't know, it's also very easy. It's actually just an interpolation. In this case, you can use this node which will make the math and here provide you the new position for the actors, for the actor we snap. Here another example of you've seen already in every of those stands there is this green preview appearing. So it's actually a blueprint that uses the Modular Snap System plugin itself. It uses the snap actors node with test flag, and it can work in completely automatic mode. So you can just give it the actor you want to you're holding in our example, and the parameters you have for the snap settings, and then it will show the preview. And another thing that it's easy to change, to customize. For example, here we have, instead of the green material, we use the wireframe material, another material. You can find this blueprint in actually in this example project. No, I'm sorry, it's not in the example project. It's in the when you have the plugin, it's in the plugin content. Here you have this blueprint preview actor, so you can go there, and actually the material is a parameter of the plugin. And finally we have this stand which explains the discovery nodes we've seen before. In the example we were building a pipeline, and this one you give two pipes, two actors A and B here, these actors that are in the this one and this one, and then it will look if there are connection between the two, and return you true and false, and return you also all the actors that are in between. So here we will just iterate on those and change the material to the blue glowing one. And that's more or less, there's some other nodes too, but more or less that's the more important nodes you have to use in your you may use in your plugin. Now the next room explains how do you take your own actors and use first with the Modular Snap System Runtime plugin, because here we just have various cubes and pipes, but it works with anything. As like you can see here, any static mesh or skeletal mesh can be used with the plugin. You need two things. First, and it's put here as first because it's very simple, easy to miss too. You need a collision primitive, simple, and you need the collision to be enabled. So here I have an example, and this white cube, it has only physics collision, no query collision. And otherwise it's the same cube though. And as you can see, nothing happens. You see, I will not snap. The blue and the red work, but the white, no, just because it doesn't have collision. That's the problem. And the point number two, how to define how the actors snap together. So you do this, and you took your actor and you add static mesh sockets to it, or skeletal mesh sockets. And here I made a little representation of those that show you the socket and the name of the socket. And the plugin will simply see those. It doesn't see really actors, it sees those sockets. So, and when I try to move it and I call the snap actors search for snap method, it will find for the actor I hold and for another actor in the world near it, it will find the nearest matching socket. And when I release it, it will make ensure that those two, in this example cube 10 on this one and cube on the another one, they will be located in the same place. You see? And another important thing is that the name of this socket is by default important. So for example, you have pipe and pipe 1 and pipe 2, they all work, they all snap. But if I try to snap a pipe with a cube here, it will not. That's the default behavior that can be redefined. It's the name, which is important to understand that, for example, for the cube, you have different possibilities to snap two cubes together. So we define it here. So to allow for that, we only will look on the first part of the name, for example here, socket. And if you have underscore something in the name, this part will be ignored. So if you have a cube, for example 1 and cube 6, whatever, the part after the underscore, so 1 or 6, will be ignored. But take care to put the underscore, because if you call it, for example, socket 0, socket 1 for the plugin, that's two different names. Okay. And another important thing to note for those sockets, it's their orientation. Here it's represented by the little transform here. So as you can see on all of those, and on the cube there too, they always have the red x-axis pointing like outwards, and the two other axes, they define the plane of the snap. So here I have those pipes that just have one socket each, and we can see it will work like so. That's also is the default behavior that can be redefined in parameters. By default, it will align them precisely like so, and when it aligns it, it makes like a cross. The two transforms are exactly opposing each other. And something that also this example illustrates, that if the angle between the x-axis is too big, it will not see it. You see? But that also is a default that can be redefined. And now the last thing about those sockets is that not only you can have different names, so they will not snap, like you've seen here, the pipes and the cubes, but in the same name you can add a sign, a plus or minus. And if two sockets have the same sign, you see those meshes will not snap. So it's like a head, and there's a socket for the hat, and on the head it's called hat plus. So two hat plus won't snap together. And on the hat, the helmet here, there is a socket is called hat minus. There won't snap, but plus and minus will snap together, providing that the name is the same. And this is simply made because it's very often the case that you have something that is, you know, not symmetrical, so something have to snap with something else, but you don't want those hats to snap together. So this is made for that, the socket polarity. And that's more or less everything you need to know for how to sockets work. So you simply go to the, I will, just a sec, I will eject here. You just go to the, you know, skeletal, static mesh editor of Unreal, and you add those sockets. They're here, you know. Also, all of them are called cube underscore something. As I already said, underscore something is ignored. So they all for the plugin they're all equals, and they're all like define a snap point called cube, and they're all looking outside. And yeah, once you did that and you ensure that you have collision, don't forget it. And this green thing, simple collision works better than the complex one. Not really sure why, but complex sometimes it misses the connection. And so, and here this cube have the collision enabled. Default means what does it means I think block all. So it's enabled, and I can put here, I don't know, custom and enabled query in physics. At least query should be enabled. It's if physics only is enabled, as we've seen here, it will not work. And that's all. So any actor, when you have all your own meshes, your own actors, like I don't know, some pieces of a house, doors, windows, same. Just you have to find how to define those sockets in some logical way, and that it's work. In the next room, which is the last one, I will explain this struct you pass as a parameter to the, let's show it again, to the snap actors function node and some other nodes, this one. And this, because the plugin has a lot of parameters, I put them all in the struct. And here we will see the most important of them. They have two types of those parameters. First is for the search operation, for locating the snap point and the calculating the transform. And the second one is for the snap operation. The first one is for the search, is for the locating the snap point, and the second one for the snap for calculating the new transform. And that's the difference between search and snap. Let's see one by one those parameters. First, it's very simple. It's the search distance. And here we have some sliders on the wall. We can change one by one those parameters. So here I have those two cubes, and search distance is 50 centimeters. The cube it makes 1 meter larger, 75 centimeters larger. I think it's scaled. And here on the preview you can see the distance it's shown to. So if I go farther than 50, it will not snap anymore. And so using this slider I can increase it and then like snap 3 meter. Another important one is the angle. By default it's 75 degrees. So which is this angle? Is the angle between those two red axes, two x-axis of the source and the target sockets. So if I move this cube, if the angle is bigger than 75 degrees, and you can see the angle is also shown on the preview now, it's 45. You see it will not snap here anymore, even if it's the nearest socket. It will go find another one, because it will only snap when the angle is smaller than that. And that is made just because sometimes it's difficult to see things, so we don't want to snap on the other side of the cube. And the angle, you can put it to different values from 0 to 180. 180 actually will simply means any angle. So in this case only the distance is important. You can see here it will not go anywhere anymore. So that can be useful in some case not. So you can set it accordingly. Another example for the name, as we said before, if two sockets have compatible name, so for example those cube and those pipe are not compatible, they will not snap. You see, cube and pipe, they won't attach to each other. But if I ignore this, and this is made by another parameter that is called ignore socket name, I can attach anything to anything, like so. And if I disable it again, it works like so. Another important parameter is called snap OpenOnly. So here we have red and blue pipes, and they're connected already. And now if I take the green pipe and I try to insert it between two, you see it won't go. It will go here, but not here. It's because this parameter is set to on by default, and here too. If I set it to off, so I can make this kind of stuff, like like start another pipe here. And it works simply by, when I move things, it will look at each socket in the source actors and the destination actors and see if there is something in front of it. If there is something in front of it, it will consider it closed. Like here, each pipe, it obstructs the other. So this socket, those two sockets are considered closed. And if I use snap open only set to on, it will not take it to account. But if I want to, you know, like make a pipe that goes from here somewhere else, then I can put that to off and the parameters. Another example, another parameter is called snap attached to. And here we have this structure like cube, like a like a cross. So you have this green cube in the middle and the glass cubes around it. And if you look the outliner, the green cube is the parent of those glass cubes. They all attach it to it. But the sockets of the green cube are closed by the glass cube, so it cannot directly connect anything because we keep the snap attached only to on. So in this example, if I try to snap it here, no, won't work. And that is because snap attached to is to off. Now if I put it to on and I grab it again, and I grab it by the green cube, that is not really seen in the, you know, in the game, but it's, you can see it in the code after. You see, it will, in this case, it will connect. And that is the same thing that it's used in the physics example before. So we have multiple cubes, and we always hold by the top cube to which everybody is attached and weld, like here too. It's a physics enabled actor. And then even if we approach some part that it's not directly, you know, the cube we hold, it will still find it. Another parameter, it's called rotation snap. But it's also the word snap, but it's not exactly the same kind of snap. And here we have those two pipes. And if I rotate it around x-axis, you can see that it will possibly have 4 positions. It's because the rotation snap is set to 90 degrees, though. It will snap at each increment of 90 degrees. And which is this 90 degrees exactly? It's actually the angle between those two transforms. So if you rotate around the x-axis, x-axis is the vertical axis here. It's a little bit small, but it's that goes from up to down. If you rotate it around this axis, it will snap at every 80 degrees. There's 4 possible positions. If I put it to 3060, it will snap only exactly, precisely, transform to transform. So the two transforms look like a cross if you look at them. They're exactly opposite. If I put, for example, 120, no, there is only 3 possible location. And then if I put it to 0, very important value, it will snap anywhere. So it will just keep the same position on the x-axis, but still it will, as you can see, it will snap it on the epsilon z. And that it's also configurable. Here we can, another example where we manipulate the y-axis alone. So here this pipe is turned, so the y-axis is vertical now, the green one, and you see it will only snap 2 others. And of course I can put it to like 30, 60, 120. Now it works like before. I can put it to 10, and here it works by increments of 10 degrees. You can also take all those 3 rotation axis snap values and put them all 3 to 0. And that's exactly what we are doing here. Nothing. Now it will only snap the location, and it will keep the rotation like it was in the word before the operation, you see. It may be useful for something too. Like, I don't know if you snap some, not really regular objects, but something like that. So up to now we look at those snap rotation snap settings like part of the snap setting structure, but you also can define them by socket. So here we have different pipes, and as you can see, the socket have, I'll all call it pipe underscore rx something, and this is something that we call socket parameter. So this is the part that is after the underscore, so it will be not looked for the search, but will look at for the calculation of the transform. And here, for example, if I put underscore rx 45, it means it will snap at 45 degrees. And this one, it has no parameter, so it will snap like it's the default. In this case it's 90. This one, for example, it has 3060 in the parameters, socket parameters in the name, and so you see it will only snap precisely. And if you disable them, of course they will be returned to default, so in this case 90 degrees everybody still. That's it. And similar to rotation snap, there is also the scale snap, and the scale snap also can be specified in the setting structure or in the parameters. So here we have the scale snap disabled, and you can see it will not change the scale of the cube. Those are just the same cubes like before, but scale it. And if I set that to on, now you can see the cube will scale too. To make when you use if you use a scale snap, take care, because it's the way the snap work, the scale working on Unreal, it's a little bit tricky. It's always in the local space of the actor. So if you have some cube that is not scaled proportionally in all 3 directions, and you attach it with scale snap on, it may scale. It will scale, but not always in the way you think it will. And that's just because that's how the scale work. That's more or less all for this demo. Now just I present you how it is organized. Here when you download it, it comes of course without the plugin. You have to get the plugin on the marketplace, and well, those are the assets from the content examples from Unreal Engine, so those rooms and some pieces. And the properly Modular Snap System plugin contents are here, and you have different, all those pipes and stuff like that. The two maps are here. Content example is this one, and there's a little like a game. Another example. And in the blueprints you have different things. The most important is this BP MSSR character, and that's the actor we use here, so it's commented, and you can see how things works. For example, that's the snapping. So for example, like when we release the mouse button, we will go here and check if we hold something as our physics handle, and then call this method snap actor with search until and true. And if we snap something, then we will play the smooth move. Before that, we will call a method pre-snap, a post-snap, or simply press snap. Pre-snap will disable the collision and the physics, just because otherwise our actor that is will smooth move, it risks to collide with everything. We'll disable it in pre-snap and re-enable it in the post-snap. That's just the code of the example. You can look how it works. It uses tags to know what actor to snap, to grab, and which one not to grab. So you can look at those here. And another one is the editor pawn. It's the one used in those examples with with pipes here. This one. This is this one. And this one, it implements the manipulation of the actors with the mouse. So it's also fairly commented too. And another maybe important thing in this level, as you've seen, different stands have different settings. So it's made by this blueprint called BP override volume. So it's simply a collision box that will check if the actor the player enter there, and then it has those snap settings, I'm sorry, here, and it will reset them on the actor. And you see here search distance, the things we've seen, and the actor, of course, it has also those defined somewhere here, and it passes that to the snap. So every time you enter in one of those volumes, it will change something in those settings, and every time you exit, it will put it back like it was before. So that's it. Thank you for watching, and goodbye.